Last year, I spoke at Next.js Conf about how we use React Native with Next.js to build the mobile app and website for BeatsGig, using a single front-end engineer and one code base. And the response surprised me. It turns out I wasn't alone. There were hundreds of developers out there excited by the prospect of using the same code base to build both websites and apps. We all love React, but the idea of using React Native on the web always felt out of reach. It was nothing but a pipe dream. But finally, it was within grasp. Suddenly, a whole community got built around this stack. There were many people who were trying to contribute and who wanted to use this in their products. But there was just one problem. Navigation was still unsolved. So I collaborated with dozens of people on this pull request, and after hundreds of comments and months of work, we finally came up with the right solution. The idea would be to use URLs to trigger navigation across both web and native. That eventually turned into a library called Solito. On the night of releasing it, Solito made its way up to number 3 on Hacker News. Then, in June, Charlie Cheever announced that Expo would be treating the web as a first-class citizen, and would prioritize the Solito stack as its way of doing things for the web. So let's look at some code. My plan with this talk is to give you an overview of where the React Native Next.js stack is today, to help you decide if it's ready for you to take out for a spin, whether for a side project or a production app that could be used by millions of people. We'll look at the recent innovations in navigation and file system routing, cross-platform authentication, drop-down and context menus, and finally, the new updates in React Native Web's CSS and styling compatibility. Up first is navigation and file system routing. This has historically been the most challenging part of sharing code between websites and apps, and we'll primarily focus on the use of two libraries, Solito and Expo Router. Let's see how they work together. Solito is a library dedicated to pairing together React Native with Next.js, with a primary focus on navigation. It comes with a number of useful starters, from a blank one to a Tailwind CSS one, which we'll touch on a bit later. Solito has a link component, which is a drop-in replacement for NextLink, as well as a useRouter hook, which looks a lot like useRouter from Next.js. It also has some useful things like createParam, which returns a type-safe useParam hook. This lets you read in and update search parameters on both web and native. So the one missing piece is how to do file system routing on native. And with that, we'll be relying on Expo Router. Expo Router is a new, very exciting project by Evan Bacon and the team over at Expo. Now, keep in mind that what I show you here is still experimental. That said, they're releasing things very quickly, and I'm really excited for the future of this project. All right, let's see how we do file system routing. Here, I have a React Native Next.js app in a monorepo. This is a typical Solito starter, so don't worry about seeing all the code. I'm going to share this at the end. So first I have a packages folder, and this has my different monorepo packages. This is a pretty simple one. In my features folder, I have a home screen. And so this is the same screen that's used to the right on the website and the app. So it's a very basic one. I'm just going to add an exclamation point, and here it updated in both places. So notice here that we have this component called a text link, and this is importing from Solito/link instead of next/link. Well, when I click on this page, it opens this different URL, so users, just like a normal Next.js app, and it does the same thing on the app. So first for Next, we have this pages folder, which is very typical, and all we need to do is import and then re-export the screen we have. So we have our shared screen that works on both platforms, and Next.js just needs to re-export it. Now the Expo app does the same thing in an app folder instead of pages. We have index, and then we have our users page here, and using Solito, you can share the same code to get from page to page. The problem is, when I open this on the app and I hit go back and keep navigating back and forth, it's not really a native experience. I'm expecting some sort of stack transition in between screens. So let's see how we can implement that. First, in our app folder, I'm going to add a folder called stack with parentheses around it, and I'm going to drag my pages into that folder. Next, I'm going to make a file next to that folder with the same name, parentheses stack.tsx. This might look a little bit weird, but it's what Expo calls a fragment route. It lets you have layout components that don't affect the URL. In this case, because this is wrapped in parentheses, it won't affect the URL, and it'll still just be /users and /empty for index. Okay, so the last piece here is in the stack.tsx file, we need to export some sort of layout component. And luckily, Expo Router comes with a lot of pre-built navigation UI thanks to this library called React Navigation. So to keep it simple, I'm just going to import native stack from Expo router, and then I'm just going to default export it. And that's it. Now look to the right here for the iPhone app. I'll make it a little bit bigger. We now have this header at the top. And when I navigate, it transitions in just like a normal iPhone app. It might look a little bit slow here because it's recording, but this is just a fully smooth built-in navigator. It's pretty cool. Let's see how we can add some customizations to this stack, like changing this index name to maybe be home. So in my layout component here, instead of just default exporting the native stack, I'm gonna call it my stack. And in here, I'm gonna have my own screens. Okay, so let's have the index screen. That's gonna map to this index file here. So it's basically letting me set the layout for that component. And I'm gonna add options, and let's just give it a title of home. And now up here, we'll see that the header will update. Now it's called home. So let's just try that one more time. I'll open this users page, but I probably want this to capitalize. I'm gonna add a screen. The name will be users. And for options, let's put with a capital U, users. So I'm not gonna save quite yet, but notice here, and I'll hit save. And there we go, and it updates. And you can do a lot of other things here. Like you can customize the header. I could even hide the header altogether. Header show, wow, Copilot somehow knew that I was saying that. And there it just goes away, right? But I can just get rid of that here, and then it shows once again. This is where your app and your website should differ, the layout outside of the screens. And Solito is built in a way that lets you do just that. You now know how to use file system routing in a React Native Next.js app using Expo Router together with Solito. And there's one important takeaway here. Notice that in the iPhone example we just saw, we were using a built-in iOS navigator, which comes with pre-built opinionated UI, like a header at the top and transitions in between states. On the other hand, I didn't add any layout to the web navigation, like a header or a sidebar. The reason is websites should typically implement this kind of UI from scratch, while native apps should use built-in navigators, like stacks and tabs that come from the platform, to make sure that we're matching the user's expectations. This is why on the Solito docs, I wrote that your screens are your primitives, which are shared across platforms. And it's up to each platform to render those screens the way that its users expect. We want to share code here, but we don't want to go overboard and end up with apps that look like websites or websites that are trying to look like apps. We'll see more examples of this as we move on to authentication. In the next section, I'll show you how we use Firebase Auth on the BeatsGig website and native app. Next, we'll look at protected routes, ensuring that users can only see certain screens when they're signed in. And finally, I'll show you a better alternative to auth redirects. To set up Firebase Auth across platforms, it's pretty intuitive. So here I created 3 apps, one for the website, one for the iOS app, and one for the Android app, and I downloaded their config files into my project. So in my app.json, which is my Expo config file, here in the iOS, I added the path to this file, and in Android, I did too. The last pieces here are just installing the packages. So instead of packages/app, I installed Firebase, which we'll use for the website. Technically, you could actually use this on the app too, but I much prefer to use React Native Firebase, a dedicated library that actually uses Firebase's iOS and Android SDKs under the hood. To do that, inside of the Expo folder, I actually installed React Native Firebase's auth and app packages. The reason I didn't put this in my monorepo package here like I did before is React Native Firebase has native code. In order for that native code to be bundled into your project, you need to install that package directly in the app. The last piece is to write some code. So here I have an auth folder, and I created a Firebase folder inside of that. And there we have index.native.ts and index.ts. On iOS and Android, it'll go to the native file. And on the website, it'll use index.ts. Now I'm gonna just paste in some functions that we're gonna use, like sign in anonymously, sign out, and other things like that. All I'm doing here is importing these from React Native Firebase and re-exporting them. So on to index.ts for the website. I'll import the methods I need to initialize Firebase. And finally, I'm gonna export all the same methods that I just created in index.native.ts. So I'm gonna save this, and let's just look at these 2 files side by side. So on the left, we have index.native.ts, and on the right, index.ts. It's important that these 2 files export functions or variables that match the same names. And here, we're able to share our Firebase code across platforms and use these methods anywhere. Let's use these functions to let users sign in and do cool things like protected routes. Let's start by looking at the world's simplest sign-in screen ever. Here we have sign in, it's a blue button. The user is going to get signed in anonymously. This is their UID, and on the app, I'll hit sign in as well. Don't have loading states or anything like that, just keeping this very basic. The functions being called here are the ones that we just made. So I'm calling these from app/auth/Firebase. We also have this use auth hook. It's using use sync external store from React. It gets triggered whenever the auth state changes, then it just gets the current user. And here on the server, I just said that the user is null. Now that we know how to sign in and out of our app, let's look at a simple yet effective way to do protected routes, making sure that users can only see certain screens when they're signed in. Here I made a users list screen. I made this dark mode so that we can distinguish the protected from non-protected routes. Also, I got pretty tired of how ugly that white screen was. So here, if I click a user, the URL changes, and on the app, the same thing happens. One thing to notice is at the bottom, we have a new tab bar. So I'll show you how I did that and how we have this nested stack inside of a tab, which is referred to as nesting navigators on the native side. So here inside of apps, I have Expo, I have app. I changed my stack that we used to have here to tabs. And if I open the tabs file, I now have the same layout and the same API as our stack that we had before. Inside of this tabs folder, I create a file called users. And this is controlling the users folder. So as long as a file has the same name as a folder, it's the layout component. And so now here we have stack, which is controlling the users/index and users/ID. And that's how you can do a nested stack inside of a tab. So back to the tab. How would we do a protected route? Inside of my tabs file, down in the users options, I can pass href, and if this is null, it'll hide the tab. Notice that users is gone here, and if I comment this out, it shows again. So here, I'm gonna simply say, if the auth exists, then this stays as undefined, which means the tab is still shown. And if it does not exist, I'll set it to null. And notice that the tab has been hidden. So if I go back to home, I click sign in here, and now the tab shows at the bottom again. And now we have a protected route. However, on the website, users have full control of the URL. So how do we protect this route on the website? Plus, you can actually technically get to any URL in the app via a deep link. If I call this deep link right now from the console, I will still have access to that screen. So here I can run this command to open the user screen, and notice that it still got there. So the final piece is, how do we handle a redirect when someone gets access to a screen that we don't actually want them to see? So I'll show you how we handle this last step for BeatsGig. I created a component called authGate with a really simple purpose. Show one component if you're authenticated, and otherwise just show this sign-in button. What's nice about having a component like this is you can add some customizations to it per screen. So I'll show you that in a second. Let's start by just wrapping our users page with this. I'll start with the list. I'll wrap this with authGate. And now both screens are not letting me go in. But if I sign in, then it shows this page. And the same thing happens here, and that's pretty easy. Let's say I want to add some customizations. For example, I could say the thing they want to sign into, sign in to screen name. So now on the authGate here, I could call the screen name users. And now when I'm signed out, this updates here. So if I sign in, I now see the users page. So I prefer to do this. It lets you use React state rather than using imperative redirects to go to other pages. Next, let's look at menus. Even companies as innovative as Figma have to waste many engineering hours getting drop-down and context menus right. Now, if you're building for the web, you have some great options, like Radix UI and Headless UI. And as I've built for React Native, I've always been jealous of these libraries. So let's look at a side-by-side example of a website menu and a native app menu. And finally, I'll show you how we solve the menu problem once and for all for BeatsGig. Here we have a side-by-side of the Twitter website and native app. Let's compare what the menu experience is like on each one. First on the left, if I go to this menu right here, I get this delete tweet option, I can unpin this from my profile, change who can reply, things like that. And this is a pretty web-specific menu UI. So to get this similar kind of menu on the app, I'm gonna just long press on this tweet, and I get the native equivalent of a context menu. On native, we don't have a right click, of course, so long pressing typically gives us the same experience. And this gives us this kind of pop-out preview of the screen. I can drag it up and down. And one pretty cool thing is, notice that here the tweet is to the right of the avatar, but in the preview, the tweet is below the avatar. And that's because it's showing us a preview of the detail screen. iOS lets you show a fully different component here in this menu preview. And at the bottom, I can click between these. If I shrink this a bit, the menu hides. It has some incredible positioning logic and overall feels really smooth. I spent a long time trying to get cross-platform menus to work in a way that shared code. And I learned that while I want to share code while I'm writing it, the implementation on each platform doesn't have to be the same. And this is similar to what we looked at earlier with navigation. On web, I want to start with unstyled components and build the menu to look like my website. But on the native app, I want to have an experience that feels native. and I can rely on the built-in native components to do just that. And here I'm going to show you that these Twitter menus that we're looking at aren't actually using Twitter. In fact, this is all built using React Native and React Native Web. Let's see how it's possible. Back in October of 2020, I started asking around to see if anyone knew of a good popover library to make the primitives necessary for a menu. In fact, when I released Modi, I wrote in the docs that popovers were still a very unsolved problem in React Native, without even considering the website. Then I came across a library from Dominant Go, which lets you use built-in iOS menus with React Native. So I started working on an experiment. What if I could use the Radix UI API, and under the hood on iOS and Android, it would output the built-in native menus? That idea soon became a library called Zigo, and I released a beta version at app.js.conf in Poland this past June. Today, I'm excited to share a stable 1.0 version of Zigo, a library for building drop-down and context menus across platforms. Let's see what it looks like to use it. Here we're back at the example we saw a little bit ago of the menu. Like I mentioned before, this is not the real Twitter app. I actually just took some screenshots to remake it for the sake of the example. So here I have my feed component, and it takes in a render tweet function. So I'll hide some of the elements and we can take it piece by piece. So first I have my trigger, and inside of my trigger I have my tweet item. So this is just this list item. And this is going to be the trap for right-clicking on web and long pressing on native. So now we just need to add our menu items, and that goes inside the context menu.content. So here we have first the preview, which is showing us the different element when we're long pressing. So notice here when I long press this, I get this preview component. So if I hid this, now when I long press the menu, instead of getting this different preview, I'm just going to get the normal element showing up. So notice here that it's the exact same element, but if I add the preview back in, then I'm going to get the actual next tweet screen popping up. And there we see that. Next, I can just edit the actual names of these menu items. So I could change this from delete tweet to delete tweets, put with an S. And there it updates here. I could remove the destructive option from this, which will make it not be read anymore, but I'll add that back on. And that's it. And this all works across platforms. On iOS and Android, it uses the built-in native menus and doesn't share any styles with web. And on web, you can pass your own styles, and you're using Radix UI under the hood. We get the best of both worlds and still get to use this awesome API created by Radix. For the last section, I'll be discussing some exciting recent innovations with React Native Web's styling and CSS compatibility. Now, even though I believe that React Native Web's abstraction of CSS is one of the more impressive web libraries out there, for a long time, many CSS authors were pretty hesitant to adopt it. The critiques were a bit understandable. For example, React Native doesn't have media queries, which means that React Native Web also doesn't have media queries. The only way to use them is to measure the screen dimensions on the client using JavaScript, and then to conditionally apply styles in render. As a result, things like server-side rendering haven't worked with responsive design and React Native Web together. I'm going to take you through a brief history of this decision, and then show you why you should start taking React Native Web styling more seriously. Back in 2018, React Native Web announced plans to deprecate the class name prop. This meant that you can only style components using the style prop, making sure that you stay within the API provided by React Native. This made total sense. The whole point of React Native Web is to restrict you to these sturdy APIs, and by letting you use a class name prop, you can inject any CSS that completely breaks compatibility with it and ensure that your apps are not being styled the same way as your websites. Even though I think this was the right decision, it came with some drawbacks. You couldn't do server-side rendering with media queries, for example. So many people were debating for a long time of what we should do about this. When I was building Dripsy, I struggled with this a lot. And if you Google server-side rendering with React Native Web, you'll probably find a decent number of threads where I was thinking through this a few years ago. The problem was I had to decide between circumventing React Native's way of doing things and using my own hacky solutions, or building an easily maintainable, sturdy API that would keep working over time and stay within the confines of React Native. I ultimately decided to do the latter, to keep things simple and maintainable over time. However, this past June, React Native Web released version 0.18. This version uses a new styling runtime under the hood called StyleQ. StyleQ is a performant runtime for merging CSS class names. And while you're probably never going to use this building your own app, if you're building a library, you should be aware of these APIs because it finally lets us do those things we couldn't before. I think this is a huge innovation in React Native's compatibility with CSS, and it has a priority on making sure that you can do static extraction well. As a result of this release, some interesting new libraries have been sparking up, and I'm going to highlight 2 of them right now. Up first is NativeWind. NativeWind is a library that lets you use Tailwind CSS in React Native. First, for iOS and Android, it has an optional compiler. If you add its Babel plugin, it will read your styles at build time and turn them into style objects, without needing to parse strings at runtime. Meanwhile, on the web side, it doesn't need any compiler because it's simply forwarding down the Tailwind CSS class names. On web, you're just using Tailwind. There's no special React Native code being used to generate style objects or anything like that at runtime. I think this is pretty exciting because you can finally use Tailwind CSS in React Native and React Native Web without compromise. The other library to highlight here is Tamagui. Now, while Tamagui is still in beta, it's a pretty interesting project. Tamagui is taking on a much wider scope than a library like NativeWind or Dripsy. Tamagui seems to want to solve it all. While also optional, its compiler does some intense things for the web, such as view flattening and turning views into divs and texts into spans. Now, my philosophy with Dripsy has always been to avoid things like compilers. I typically like to stay within the regular APIs of React Native to make sure that the surface area for bugs is small and that the library is always maintainable. That said, everything has its trade-offs. While adding compilers does add possibility for more bugs, it also gives us an opportunity to improve performance quite a lot. In fact, on Tamagui's website, there's some very interesting benchmarks, where in some cases, it seems to be outperforming web-only CSS libraries that are pretty popular. So this is all pretty interesting. And if you're a library author, I encourage you to check all this out and see if you're interested in contributing to one of these libraries, or potentially creating your own, because we now have an incredible API for cross-platform styling without any of the limits on our ability to use CSS the way we want to. And that is all I have for you today. If you enjoyed this talk, I encourage you to follow and reach out to me on Twitter at Fernando Rojo, where I'll be discussing a lot of the future things that we're working on. I can't wait to hear the ideas you have to continue pushing forward the cross-platform stack of the future. Thank you.